Hi ladies and gentlemen, so today we're looking at 2.4, completing the square. So we've looked at a variety of ways up until this point on how to solve quadratic functions. We've done graphing and we've done factoring. So now the next method that we're going to have to put in our toolbox of how to solve these type of problems, or in other words, how to find where they cross the x-axis, is to use this method of completing the square. We're also going to use this method to take a function from standard form and put it back into vertex form. So we talked about vertex form at the very beginning of this unit, and we looked at writing something that was in vertex form and standard form, and now you're going to learn how to do that process going the other way. So looking at the warm-up, it says factor and fill in the table. So I do want you to take a moment to just work on factoring and seeing if you can find a pattern in this table. So pause the video and press play when you're ready to see the answers. Okay, so hopefully you've given this a try on your own. That's going to make learning this a little bit more authentic if you have. So looking at the first one, we have x plus 8x plus 16. This factors into x plus 4 times x plus 4. But a shorthand way of saying that would be to just say, well, x plus 4 squared, instead of writing it multiplied by itself twice. X squared minus 10x plus 25 would be x minus 5 times x minus 5, or in other words, x minus 5 squared. Notice a pattern yet? When we have x minus 7, which is then being squared, that expands out to be x squared minus 14x plus 49. Now when we look at the next one, we have x squared minus 20x, we don't know what c is, and then factored form, it just says x minus some blank. Excuse me. So we got to figure out what is the pattern happening between our b and our c values and what our factored form looks like. Well, notice c in the first one, which is 16, and how does that relate to 4? Or how does 25 relate to 5? Or how does 49 relate to 7? Those are all perfect squares. Meaning if I square root 16, I get 4. If I square root 25, I get 5. If I square root 49, I get 7. So I know whatever number I put here, if I square root it, I need to get this number over here. Well, that's not helping me with filling this in because I don't know what c is, so there's nothing for me to square root. So what's the other pattern? Well, our b values, such as 8, if I take positive 8 and divide it by 2, I get positive 4. If I get negative 10 and divide it by 2, I get negative 5. Negative 14 divided by 2, I get negative 7. Aha! So negative 20 divided by 2 is negative 10, and that gives me my factored form. If I take 10 and I square it, I get 100, and that gives me my c value. Looking at the next one, x plus 16x. Half of 16 is 8, so my factored form is x plus 8. 8 squared is 64, and that gives me c. The next one, half of 7 is 3.5, and 3.5 squared is 12.25. Writing this using just letters with b filled in here. Half of b is b over 2. Then I take that number and I square it to get my c value, so I could write that as b over 2 squared. Using this shortcut method or pattern to factor x squared plus 6x plus 9, I know that the square root of 9 is 3, or half of 6 is 3, so my factor is going to be x plus 3 squared. What we've just done is we've talked about some binomials and trinomials. So just as a reminder, binomials are quadratic expressions with two terms. That's how we write our factored form of things. Trinomials are things with three terms, which is our standard form of a quadratic function. Completing the square is a process, so sometimes we're not able to factor a quadratic nicely, so we need to complete the square to make it neater and easier for us. This usually happens when we have a quadratic in the form of x squared plus bx and there's no c, and we can create a value of c by adding it to both sides, that's going to allow us to factor nicely. So if we look at example 1, we want to complete the square with each of these. So what we want to do is we want to figure out what does this number in this blank box need to be that's going to allow us to factor into a perfect square. In other words, that's going to allow us to factor into a binomial raised to a power of 2. And we're going to go through the same process we did in the warm-up. We got to think about, well, if we take our value of b here, which is negative 14, and we divide that by 2, we get negative 7. And if I square that, I get 49. So that means this quadratic I've created is x squared minus 14x plus 49 because I know that that's going to factor into x minus 7 squared, applying this process of completing the square. So it's nice because we are in control of what that last number is. That's going to allow us to factor in this really nice way of x plus or minus some number to the power of 2. Taking a look at the next one, x squared plus 9x. I want this to factor into a perfect square binomial, so I need to come up with what number would I want added or subtracted here to x. Knowing that my value of b is 9, if I divide that by 2, I get 4.5. If I take 4.5 and I square it, I get 20.25. Looking at the last one, my b value is negative 4, so I'm going to factor this into x minus 2 squared. And in order for that to truly work, that then means I need to be adding 4 for my value of c here in the standard form of this quadratic function. So we've practiced this process of completing the square, creating this quadratic function that's going to allow us to factor in a very specific way. But how does this help us with solving a quadratic function? And so there's these 6 steps of completing the square process. I'm going to be referencing back to these 6 steps when we go through the next couple of problems, so make sure you have these nearby to reference. The first step is to collect all variables on one side and constants on the other. So we need to separate our terms with x's and our just constant numbers. Then we're going to make sure our leading coefficient is 1. And if it's not 1, we need to divide everything by whatever that value is. Process 3 and 4 is that completing the square process that we just did on that last example problem. We're going to complete the square by figuring out what half of b squared is to create our new c value. But we are dealing with an equation, so whatever we do to one side, we have to do to the other. Then we're going to factor. Then from there, we're going to begin solving for x by taking the square root of both sides and then isolating the variable. So let's put this to practice because that's really going to help make these 6 steps make the most sense.